All right, you guys, welcome to the function domain and range with a little bit of interval notation example video. So when we're considering domain and range, the first thing we have to remember is what domain and range are, right? So real quick, what is domain? Yep, I'm asking you. Okay, what's range? All right, so domain is the set of all inputs that are valid and meaningful. So they work in our function. In other words, we put it into the function, we get something back out. And meaningful means it makes sense mathematically in the context of the problem. And then range is just simply all the corresponding outputs. Really easy. So when we're trying to figure that out, we want to ask ourselves 5 questions. I'm not going to write them up here because it's too much words. So the first thing we want to ask ourselves is, can it be negative? So whether we're talking about the inputs or the outputs, right, the domain or the range, can it be a negative value? And if we say yes to that, then we ask, can it be all negative values? Okay. Once we get that figured out, we ask, can it be 0? Then, can it be positive? And if we say yes to that, can it be all positives? So those 5 things right there can help us cover the entirety of the number line, and those are the kind of main issues: negative, 0, positives. So with that in mind, we can kind of build out this whole idea. Now, if we consider back to our function that we've been dealing with, fx equals 3x plus 1, we can figure out the domain and the range. So, asking ourselves those 5 questions. So domain, so we're asking ourselves the input. Now, there's no context to this problem, so we don't have to worry about meaningful. We only have to worry about, does it work? If I put that value in for this x, I multiply it by 3, and I add 1, do I get a number back, right? Our example in the lecture was square root of 25, or square root of x, right? 25 worked, square root of 25 is 5. Square root of negative 25 didn't work because we aren't dealing with imaginary numbers. So, if we look here, we ask ourselves those 5 questions. Can it be negative? Can I put a negative number in for x? Yes. I can multiply a negative number by 3. I can add 1. No problem. Can it be all of the negative numbers? Is there a negative number out there that doesn't work? Or what about negative pi? Yeah, we just get an irrational, weird number, right? But it works. So all of the negative numbers work. Okay. What about 0? Right? Absolutely, right? 3 times 0 is 0. 0 plus 1, 1. Done. Okay. Positive numbers. Can we do positive numbers? Again, absolutely. What about all positive numbers? Yes. So since all 5 questions were a yes, that means every number works in here. Every number is in the domain. So that is very simply means we go from negative infinity to infinity, right? When we're doing interval notation, right? Smallest to largest. Okay, so then we just have to figure out, what do we need for the nth? Do we want parentheses or brackets, right? Remember, we cannot include infinity because infinity is not a number. So here we are going to put parentheses, okay? So negative infinity to infinity. All right. Now let's think about the range. The range of this is really nice and easy, okay? Because we think about the outputs, right? So range is the corresponding outputs. Can I get a negative number out of this? Yeah. If x is negative, right? Something bigger than negative 1/3. Yeah. Or more negative than 1/3. Absolutely. We can get all negatives. We can get 0, right? What x value makes 0? Well, negative 1/3 times 3 is negative 1. Plus 1 is 0. So we can get 0. We can get positives out of here, absolutely, right? We can get all positives. So again, all 5 questions are yes. Our range, very easy. Negative infinity to infinity. Now, if we look at the graph of this guy, it makes it really obvious, right? I'm not going to get too crazy. This is going to be 1. Our graph looks something like this, right? It's a line, right? With a slope of 3. Well, y-intercept of 1. Pretty easy. Now, remember, domain is our inputs, right? Our inputs are on our horizontal axis. So if we look at this and we think, is there any horizontal spot? Is there any tick mark on here that would not work, right? Every tick mark you can find somewhere, go along that a vertical line of that tick mark, you can find a point on this function, right? All of them. So they all work. Same thing for our outputs, our range, right? There's always going to be somewhere. So it works. Everything is there. Nice and easy. Okay? Now, let's go with the new letter just for fun. Let's talk about that square root of x, right? Let's say g of x is square root of x. I want to identify the domain and the range. So we have to ask ourselves those 5 simple questions. Can this be negative? Ooh, excuse me. Can x be negative? So we're looking at domain. So we're looking at inputs. Can our input be negative? Can we put a negative number into a square root? Whew, chalk dust getting me. We cannot put a negative number in a square root because if we put a negative in a square root, we get an imaginary number. So first question is no, which means we don't even need to ask the second question because if we can't get a negative or we can't use a negative, we definitely can't use all negatives, right? What about 0? Some of you may be like, yeah, I know the answer to this, but we're going to circle back, okay? Can I put a positive number in here for x? Absolutely, right? 1, 4, 9. Those are all going to give us nice outputs, right? But square root of 2 is a number too. It just isn't a nice whole number. So positives work. We can do all positives. So at this point, we know our domain is going to be from 0 to infinity because I can do all positives. Now that third question, the one that I said we're going to circle back to, that tells me what the endpoint here is. If I can't have 0, I would use a parenthesis. If I can have 0, I would use a bracket. So we have to ask ourselves, what does the square root do? Right? Very simply, the square root of x, okay? If the square root of x equals a, that means that a squared equals x. So what we have to ask ourselves, is there a number? So if we can't take the square root of 0, that means there's some number. When I square it, I get back 0. And what number times itself will equal 0? Well, 0. So we can take the square root of 0, which means brackets. Okay? Now range. Range is very simple as well, right? We just have to go through those 5 questions. If we do that every time, it can make this process easy. The more complicated our functions get, we might have to check more things, but we still just follow the same 5 questions. So, can I get a negative number out of a square root? No. It means I don't need to ask, can I get a ball? Can I get 0 out of a square root? Well, yeah, we just said the square root of 0 is 0, so we can get 0 out. Can I get positive numbers out? Again, absolutely, right? Take a square root of a number, pick whatever positive number you want, square it, that's the x value that'll give us that output. So nice and easy. Okay, so we can get 0, and we can get all positives. Okay, now these 2 examples are unique in that both of their domain and ranges are the same, but that is not always true. So do not fall into this nice little allure that domains and ranges are the same no matter what. Okay. If you want an example, just think x squared, right? X squared can take in anything, but it's never going to give you a negative number back. So, if we look at the graph of this, now you may be familiar with it or may not be, okay, but it roughly looks like this. Okay. Now there's one thing I want to talk about with this when we're looking at these graphs. Sometimes we may not see symbols like arrows or solid circles or anything like that. Okay. Especially on the end, especially at the end of a graph. If we don't see any symbol saying that it ends here, there's a solid circle or an open circle saying this is the end of this graph, it stops. We assume that it continues on in that pattern forever. So this graph here is going all the way, it's going over, so we can assume that our domain will go all the way over. And it's kind of rising slowly, so we can assume that our range will rise slowly, but forever, which means it will eventually get there. And so looking at this graph, I can see that my domain is from 0, since I've got a solid point here. I don't have a very clear open circle. If there's ever a point where it's not including that, it'll be a very clear open circle. Okay. So we go from 0, and this goes all the way to the end. So our domain is 0 to infinity. Range is the outputs, right? The outputs are graphed on the vertical axis here. So it goes from lowest is at 0, and it goes all the way up. So 0 to infinity again. Okay. Now, that is a nice little touch on kind of finding domains and ranges. Now, as we get more and more advanced functions and we kind of build those things up, start to get some potential issues, we're going to talk about domain and range all the time. Okay, it's going to be a constant thing that we're going to bring up every single topic. So, I want to real quickly talk about interval notation. And I have a silly little trick that I use to help me remember what I want to do. Now, parentheses, brackets, all that stuff is sometimes kind of confusing, especially when you're first learning it. The way I think of it is a little boxcar on a train, right? So we've got our little boxcar. Let's square it up. There we go. All right. Now, if I have a parenthesis here, this car can go all the way in, right? But as you see, there's a little gap here. So if I think of this, my hand right now, as a parenthesis, it's getting there, but it's not making it all the way. Okay? Same thing with a parenthesis on an interval notation, right? Our value is going all the way up to that number, but it can't quite get all the way back there. Now, if I make my hand kind of more square like a bracket, right, that boxcar gets all the way in no problem. Right? There's no gap. It can reach that end. Same thing with interval notation. So if I say have the interval -2 to 5, so I have a parenthesis on the -2, means I go all the way down to -2, but I'm not including it. And with 5, since I have a bracket, it means I go all the way up to 5, and I actually include that value. Okay. Now, one question that we get a lot with interval notation is how do I differentiate this from the interval from the point, right? So if I have the point -2 to 5, or do I have the interval from -2 to 5? And the answer is, just looking at that, we don't know. If I wrote this up on the board, I don't know if you're talking about an interval or a point, but the context tells us, right? So if I ask you, what's the domain of a function, and you give me this, I don't think you're saying the domain is the point -2 to 5. I think it's the interval from -2 to 5. And similarly, if I ask you, what's the maximum point on this function, and you say negative this, I'm not thinking you think the maximum is from -2 to 5. I think you're saying the maximum is the point -2 to 5. So the context is what differentiates this for us. So I hope you guys learned something here. If you didn't, if you have any questions, please feel free to post in that Foundations forum so that way we can get some discussion going on these topics. I will be checking those as often as I can. Look for the next video to be put out by Wednesday at the latest. My plan is to keep publishing videos as if we were meeting on classes Monday, Wednesday, and Friday. If I get them earlier, I'll put them up early. I'm not going to just wait until those days. But those are my deadlines for myself to keep me going and keep me on track. So, hope you guys have fun, and I'll see you guys around.